Okay, looking at number 10 on the Chapter 6 Quiz Review Worksheet, first of all, notice the directions. Simplify each radical expression. Use absolute value symbols when necessary. So don't let me forget. Make sure I ask about that. Remember, besides your calculator, you can also use the blue paper tomorrow, right? So that would be something good to have handy to be familiar with and practice with. And so as we look at these, we want to talk about, can we take these cube roots? Can I take the cube root of 27? Can I take the cube root of 27? Is it on my blue paper? It is, isn't it? And I will say, maybe one of the hardest things about this is remembering we're doing a cube root problem here, yes? Not square root, this is a cube root. So can I do the cube root of 27? Yeah, the cube root of 27 becomes what? 3. Your calculator can tell you that as well. Can I do the cube root of x to the 15th? How do we do cube roots of exponents? Yeah. If you can do a cube root of an exponent, then that means the exponent 15 has to be able to divide by 3. Does 15 divide by 3? It does. And 15 divided by 3 is 5. So we're going to say x to the 5th. Can I do the cube root of y to the 24th? So again, if it's a cube root, I'm asking, can I divide that exponent by 3? Does 24 divide nicely by 3? It does. 24 divided by 3 is 8. So good news here. Everything was a perfect cube. So we were able to go straight at that. Then the direction said use absolute value symbols when necessary. Here's the deal. Can we take the cube root of a negative number, and can we get a negative answer there? Yes, you can, right? So do I ever need absolute value with a cube root? No. Anytime it's a cube root, a fifth root, those odd roots, no absolute value necessary. Your answer is right there, 3x to the 5th, y to the 8th. We only have to consider that absolute value if it is even roots, so square roots and fourth roots. Okay? And that's because we can't take the square root of a negative there. We can't have a negative answer. Okay, does that help on 10 there? Should I throw in one while we're here where we do need to talk about absolute value? Huh? 11? Okay, I was going to pick 9, but 11 works as well. I mean, both of them are even roots, so we need to consider absolute value, don't we? Okay, so let's try 11. So 11, same section, same directions. The fourth root of 81 x to the 20th, y to the 8th. So remember, we're talking fourth roots now. Can I take the fourth root of 81? Yes. It's on my blue paper, right? Fourth root of 81 is what? 3. So that's out of the radical. Can I take the fourth root of x to the 20th? Yes, if I'm going to take the fourth root of x to the 20, what do I do with that 20? Divide it by that index of 4. And I'll go ahead and write it in for the next one, yes? So 20 divided by 4 makes us x to the 5th. Can I take the fourth root of y to the 8th? Yeah, in other words, does 8 divide by 4? It does. And that's y to the 2nd. Now, do I need to consider absolute value this time? And the answer is yes, I do. Which, if you recall from what I was doing, is I just kind of, okay, because 4 is even, do you remember me doing this in the notes? I need to consider absolute value. 3 was odd, no absolute value. 4th root, that's even, we need to consider absolute value. Now, the question is, which of these pieces need absolute value to make sure it's positive? Does the number 3 need absolute value to make sure it's positive? No, 3 is already positive. Now, I did notice on MathXL, they let you put the absolute value around the whole number. But you don't need it. You don't have to have absolute value around the 3. Do we need absolute value around x to the 5th to make sure it's positive? In other words, here's a question to yourself. What if x is negative? A negative raised to the 5th. Could that still be a negative? If you do a negative 5 times, that's going to be a negative, isn't it? Are we allowed to have negatives coming out of a 4th root? No. So x to the 5th needs absolute value. And the basic reason there is because it was an even root up here, but an odd exponent answer. Okay? What about y to the 2nd? Could y to the 2nd be negative? No, because if y is negative, but then you square it, that's automatically a positive. So y to the 2nd does not need to be under the absolute value. Only thing that has to be under the absolute value is the x to the 5th.
Does it matter what order they're in? Like there'd be 3y to the 2nd and then an absolute value x to the 5th.
Technically, no. Order would not matter. Traditionally, you're more likely to see alphabetical, and with the constant first, but alphabetical is not required. And I could see why you might, put the one that does have to be an absolute value at the end. I could see that. So, yeah, you can mix the order around and still be correct. Okay. Michaela? 23, is that what you said? 22. I'll try and get it right. 22 is a good one, isn't it? I'll be honest, 22 probably ended up being a little bit more difficult than I intended. It happens sometimes when you're making these worksheets. Doesn't mean it's not a good problem. It has lots of good skills in it. And so I will take you through those skills. Let me write them down. Square root of 6x to the 8th, y to the 9th, over square root of 5x squared, y to the 4th. Let's see, recommendations on 22. Because I see x's and y's on top and bottom, because it's a fraction, I would start by trying to divide anything I can. Okay? I would start by trying to divide anything I can. Do 6 and 5 divide? No. 6 and 5, they don't divide, they don't reduce. So my whole numbers of 6 and 5 are going to stay as is. Okay. What about x's? X to the 8th and x to the 2nd. Do x to the 8th and x to the 2nd divide? Yeah, they do, don't they? Because how do you divide when exponents are involved? In order to do x to the 8th divided by x to the 2nd, you keep the base the same and subtract, yep. And what is 8 minus 2? 6. Now, where do I put that x to the 6th? Where are there more x's to begin with? On top, so x to the 6th goes on top. And notice this is all still under square roots because I haven't taken any square roots yet, have I? Now, what about the y's? Can those divide? Well, Well, remember, if you're dividing, it's can you subtract the exponents? Yeah. Keep the base the same. So we're going to keep the y. 9 minus 4 is 5. And where are there more y's? On top. So that's y to the 5th. So that's the first simplifying step I would recommend, is do any division that you can. Okay, clean it up a little bit. We have less terms this way. So right there, well, I don't know if I want to write that in or not. Now, are there any perfect squares I can take? And we could do either of two steps right now. We could go ahead and pull out some perfect squares with the x's and y's, or we could go ahead and rationalize. And I don't know, you guys might actually like to rationalize first. Or does it matter? I don't know. Preferences. You guys are like, I don't know, I'm just lost on this problem, get me through it.
Rationalize afterwards, do the other thing first.
Go ahead and simplify first. And I know that's what I did in the answer key. And you could do this either way, technically, but I do like to take square roots first. Can I take the square root of the whole number 6? Are there any perfect squares in 6? No. Same thing with 5. Those are just stuck there. What about x to the 6th? Can I take the square root of x to the 6th? How do we take the square root of x to the 6th? You take that 6 and what? Divide by 2. You guys have to be able to do this tomorrow. So can I do that? I can. So, let's see here. The 6 we can't take the square root of, right? 6 stays under the radical. X to the 6th. Can I take the square root of x to the 6th? Yes, because 6 can divide by 2. And so when I take the square root of that, what does that become? 6 divided by 2 is 3. Where do I put that x to the 3rd? It's going to go out front, because once you can divide that exponent by 2, it's going to go out front. Now, if you're looking at my answer key, I just realized I actually have another step in here that I'm kind of skipping over. I was going to do it off to the side here. What about y to the 5th? Can I take the square root of y to the 5th?
No, you can take 5.
Okay, 5 does not divide by 2. Closest number below 5 that can divide by 2 is 4. So what do I normally do with this y to the 5th? We normally then split it up into y to the 4th. No, I don't want to write it over that. We usually split it up into y to the 4th and y to the 1st. Can I do the square root of y to the 4th? Yes, because 4 divided by 2 is 2. So where does that go now? 4 divided by 2 is 2. I'm going to put that y to the 2nd out front. What about y to the 1st? Square root of y to the 1st, I can't do it, so y stays under the radical. And then what about this denominator? Square root of 5 is going to stay square root of 5. Okay. We've done all the simplifying we can. We divided. We took out perfect squares. Can I leave my answer like this? And the issue is square root of 5 in the denominator. How do I rationalize the square root of 5? And what do I use to cancel it out? What do we multiply by here? Okay, if it's just a single square root, you multiply by itself. So we're going to multiply by square root of 5. What I multiply the denominator by? We're going to multiply the numerator by. So, on top, out front, I already have x to the third, y to the second. What is square root of 6y times square root of 5? Square root of 30y. Because you can multiply a square root times a square root. On bottom, what is square root of 5 times square root of 5? Okay, you can say square root of 25, but then what does that turn around and become?
5.
Turns around and becomes a 5. Okay, so you can say square root of 25 for the moment, but then make sure you go around and say 5. Okay, guys, at that point we're done. No radicals on the bottom anymore. No perfect squares under the radical. 30 and y have no perfect squares in it. And x cubed, y squared are good outside. Nothing that can simplify outside. Okay? I know, there's a lot of simplifying in that one. Let me ask you a question before we move on to something else. Okay? Because this was a fancy example, right? As I said, turned out fancier than what I wanted. What if this problem had just been square root of 6 over square root of 5? And the directions are the same. Simplify what you can and rationalize. If the problem had just been square root of 6 over square root of 5, is there anything you can simplify here? Does 6 divide by 5? Can I take any square roots? No. So what is the one main step you would have had to do? You would have had to have rationalized?
Yeah.
And how would we rationalize that? You would multiply by square root of 5, top and bottom. Now I want to show you the basic, as I don't want to leave you overwhelmed by the bigness of this problem. But if all you can do is this one is rationalize, multiply the denominator by itself. On top, square root of 6 times square root of 5 is square root of 30. Square root of 5 times square root of 5. If you want to, you can say square root of 25. But then I'm going to say go one more step and say square root of 30 over 5. Okay? 22 had a lot of good steps in it. Here's really the basics that I need you to make sure you walk away with here. Can you rationalize if there's just a single term? Okay? Okay. Other questions? So I get to pick? Oh, you got something, Lorna?
Yeah. 37.
37?
Yeah.
Okay. I'm going to a new screen. I'm going to assume you guys are .37. Cube root of 2y squared. Write this in exponent form, exponential form. So we're trying to go out of radical into exponent, yes? Now, I will say this one does have 2 parts, so it makes it a little more complicated, but what do you know about that cube root there? How do we show a cube root as an exponent? That 3 goes where in the exponent? Goes in the denominator, right? So, and I'm debating which way I want to do this. On the answer key, I showed it as doing 2y squared raised to the 1/3, didn't I? Okay. And then I went one step after that. You might want to just skip the step I just wrote and go straight to the basics in that, okay, the y has an exponent of 2, right? And here's the tricky part. What's this 2 have an exponent of? Invisible 1. So what it might be easier to just do is, okay, the cube root, that 3 goes in the denominator. The power, so the 1 here and the 2 here, they go in the numerator, right? So you could just go straight to this over here and say, okay, this is 2 to the 1/3, and y to the 2/3. I know that's how I gave it as the final answer. The idea is knowing which goes on top, which goes on bottom of the fraction. I would focus. What if I give you more of a basic problem? 38. 4th root of b raised to the 3rd. Do you know which way to write that as exponential form? I mean, if you've been with me and paying attention, you have a 50-50 shot of getting this right, I feel like. Because you should know that we make those 2 numbers a fraction at this point, right? Yeah. So I say a 50-50 shot because then you're either going to say 3/4 or 4/3. What do I keep saying about this number right here in the radical? Or in the root? Okay, I've repeated about a bazillion times, that root is the denominator. So then that means it has to be 3/4. That would be knowing the basics of that section, which is what you need to get through. Okay? I don't have a very good one in the previous section, but let me show 33 real quick. Was your question on this one or? No. Okay. I'll go with wherever you need to go next. On 33, it's 3x to the 3/8. Okay? The trick here is that what is the exponent on 3? It's just a 1. So the trick on that one is that 3 goes out front of the radical. The basics is, can you deal with x to the 3/8? That's the basics that you need to know. X to the 3/8? Well, you've got a 50-50 shot. Is my root a cube root or an 8th root? 8's in the denominator, so it's an 8th root. The 3 is in the power. Okay? Know which way to go there. Okay, Kylie.
Can you go over 17?
Yep. I have 17 circled as a good one to look at. Okay, square root 50x to the 7th y to the 7th times square root 6x y to the 4th. Multiply and simplify assume all variables are positives. That's saying don't mess around with absolute value. That's what that's code for. Okay? I will tell you when you need to consider absolute value, and that was up on 9, 10, and 11. Now, multiply and simplify. So what's step 1? Multiply it together. It's a square root times a square root. Squish it together. Multiply. Square root times square root. So 50 times 6 is 300. X to the 7th times x to the invisible 1. What do we do when we're multiplying? We're going to add the exponent. So 7 plus 1 is 8. Y to the 7th times y to the 4th. 7 plus 4 is 11. Okay. You did the multiply part. I'll give you a point if you can do this part at least. However, if I give you a point and say it's a 3-point problem, you just missed 2 of the 3 points by not doing anything else. Okay? 300. Is the square root of 300 a perfect square? Now, when I look at my blue paper, 300 is missing. If I do square root of 300 in my calculator, no. So, what I'm going to say, 300, largest perfect square that you can find that you can divide 300 by. And this is where I say, this is where I take your calculator and start punching things in, right? Some of you are going to see this, it's going to be more obvious, but this is where I'm going to say, okay, does 300 divide by 289? No, I get a decimal. 300 divided by 256. No, I get a decimal. 300 divided by 225. No, I get a decimal. I'm going to keep going until I find something, right? What am I going to find here? 100? So this is where I break up my square roots. 300 divides by 100, and the remaining factor is 3. So that's 100 times 3. What about x to the 8th? Am I going to be able to take the square root of x to the 8th?
Yeah.
Yeah, does 8 divide by 2? 8 divides by 2. So I'm not going to break this up. I'm going to leave it as x to the 8th because it does divide by 2. Exponent, it doesn't matter if it's on the blue paper. It does divide. Can I do the square root of y to the 11th? Does 11 divide by 2? No, I get a decimal. So, you guys know the question I'm going to ask, right? Closest number below 11 that does divide by 2. That's going to be our 10. So I'm going to break this up into y to the 10th times y to the 1st. 10 does divide by 2. 1's the leftover piece. Okay. Here we go. Remember, it's a square root we're doing. Square root of 100 is 10. That goes outside the radical. Square root of 3. It's a decimal, so where's the square root of 3 go? Inside the radical. Square root of x to the 8th. Take 8 and do what? Divide by 2. 8 divided by 2 is 4. So that means x to the 4th goes outside. Y to the 10th. That's also, we're going to divide by 2. 10 divided by 2 is y to the 5th, and that goes outside. Y to the 1st. Square root of y to the 1st. This is my leftover 1. It doesn't divide by 2, so we're going to leave it under the square root. It said assume all variables are positive, so I'm not going to waste my time asking about absolute value. I've multiplied what I can up here. There's no perfect squares left under the radical, so I am done there.
Can we do 41?
41? We can.
It's an easier one. I just want to make sure I understand.
No, I get it. Some people are going to say this is an easier one. Some people are going to say, nope, I don't get this fraction stuff. It's all hard. So, okay. 41 says 81 to the negative 1/2. First thing I notice is there's a negative exponent. How do we deal with negative exponents?
We put it in a fraction.
Okay, we take it to the bottom of a fraction, right? So you have to do that first. Don't try and make this a radical. You have to make this a positive exponent. So it's going to become 1 over 81 to the positive 1/2. Now that it's a positive exponent, what does that positive exponent tell me?
The square root.
Yeah, a denominator of 1/2 in the exponent tells me it's a square root. I mean, technically it's a square root of 81 to the first, but all you really have to worry about is the square root there. And what is the square root of 81? 9. So then this is going to become 1 over 9. Don't try and give me some decimal answer. I don't want a decimal answer. Okay, I want 1/9. What about 42 while I'm here real quick? Do you know how to deal with 42?
We can go over it anyways.
Huh?
We can go over it anyways.
I look at it this way. I have it as a circled one, which, you know, that's kind of a key of make sure you know how to do something like this. Cube root of x squared divided by 6 root of x squared. Can I divide a cube root and a 6 root?
No.
No. So what, this was just lesson 6-4. What did I teach? If we can't divide them, we're going to go to a fraction form. So, the cube root of x squared. Is this x to the 3 over 2 or x to the 2 over 3?
2 over 3.
Okay, 3 is the root. That's my denominator. Divided by x to the 2 over 6. Now, we need a common denominator. You can go either way here. Probably the easier common denominator. What do we know about 2 over 6? Can that reduce to 1/3? That's what I would do. If you got a common denominator of 6 and did 4/6, that works too. But I would say this is x to the 2/3 divided by x to the 1/3. How do I divide when exponents are involved? The base is the same. We keep the base the same. So we're going to keep the x, and we're going to subtract the exponents. So 2/3 minus 1/3. What is 2/3 minus 1/3? X to the 1/3. Traditional rule has been if they start you with a radical, you should probably try and end with a radical. So x to the 1/3 is what root of x to what power?
X cubed.
The 3 in the denominator says it's a cube root of x to the first if you want to put a power of 1. Okay. Good things to practice. Do I have time? Do we remember how to rationalize on something like 28? Do you remember how to rationalize something like that?
Yeah.
I'm gonna have to multiply by the conjugate of the denominator. What is the conjugate of 2 plus the square root of 5? 2 minus the square root of 5. Good. On top, you would just distribute. How do you multiply on bottom technically? We haven't practiced any of it today.
Foil.
Foil. Do we remember how to foil? Okay. That's another key thing there. If I distribute this on top, 7 times 2 is 14, minus 7 times square root of 5 on bottom. When you foil, guys, you've got to be able to foil tomorrow. 2 times 2 is 4. 2 times minus square root of 5, so minus 2 square root of 5. Square root of 5 times 2, plus 2 square root of 5, minus square root of 5 and a positive square root of 5. Minus square root of 25, or I could just say minus 5. The idea in the denominator is what happens. Middle guys cancel. I have 14 minus 7 square root of 5 over 4 minus 5, which is negative 1. And I bet I didn't leave it like this, did I? So I would say go one more step. If you divide negative 1 into both of these, it just changes the signs to negative 14 plus 7 square root of 5 is what I would guess my answer key says. And I know that was quick because I was trying to beat the bell here. But if you don't remember how to FOIL, you need to go back and review that, right? Make sure you have checked over your answer key or checked over your worksheet with the answer key. Okay? So, plan to quiz tomorrow. 2-hour delay will be debatable. If we're on e-learning, we won't be quizzing.
I want to eat some.
We'll have a plan B. I just don't know what plan B is yet.
What do you think about that? I like those 2-hour delays.
I really, before school today, before I talked to me, I felt positive that we just wouldn't be here, honestly.
Yeah.
But I'm not sure that the wind chills are going to be quite cold enough, believe it or not.
It says the wind chill's supposed to be 16.
And they're, basically, I think some of it's going to come down to if other schools do.
Yeah.
So, but they're saying it needs to be closer to 20 below before we will do something.
Yeah.
So, I don't know. I don't know.